In this lesson, we're going to talk about the area of circles. So just to review that we went over in the last lesson, okay, the parts of a circle, the radius is the line drawn from the center of the circle to the edge, okay, it's half the length of the diameter, okay. The diameter is a line drawn through the center of the circle from one edge to the other, and it is twice the length of the radius, so 2 times, okay. The diameter is 2 times the length of the radius. Radius is half of the diameter. A sector is an area of the circle formed by 2 radii and 1 arc, okay, like a piece of a pie. All right, so a sector then is this part right here. Okay, so that would be the sector. To determine the sector, all right, it's basically like determining the fraction of the circle that the sector makes up, all right? So what you want to do first is find the degree of the arc, all right? That's how much space this arc covers, all right? And the arc, the degree of the arc is just the angle that the triangle makes up here on the inside, okay? The angle that's right across from it. So here, see how this has a right angle right there? That means that the arc is 90 degrees, okay? And then we know that the whole circle is 360 degrees, so we just take 90 divided by 360, and it's 1/4, okay? So remember, when you're looking at a sector, you're always going to end up with a fraction, right? Because the whole circle would be 360 over 360, which is 1, right? So any part of the sector is going to be less than 1. The area is the space that fills up the circle, okay? And you find it by taking pi r squared, okay? So pi times r squared. And remember, when you have exponents, they have to come first. So you have to multiply the radius times itself and then multiply times pi. So here it says, use circle Z to find the exact and approximate area based on the given information. Use 3.14 for pi and round your answer to the nearest kilometer. Okay, so here it says if VZ, okay, right here, is 12 kilometers, all right, then we want to find the area, all right? So VZ is a radius, okay, so we have pi 12 squared. Okay, remember, we want to take the squared part first. Okay, so we have to take 12 times 12, which is 144. Okay, so the exact answer then is 144 pi, or pi 144. Usually you want to write pi at the end. Okay, so we have 144 pi, or we can take that 144 and we can multiply it times 3.14. And then it says, and then our area is 452.16, and it says round it to the nearest kilometer. That means we don't want any decimals here, okay? Since this is a 1 right there, then that 452 just stays the same. So it'd be 452 kilometers, okay? Now it says if UW, okay, UW is a diameter. If UW is 9, okay, then the radius is going to be half of that, okay? So if we take half of 9, okay, then we're going to get 4.5. So for that one, we're going to say pi 4.5 squared, okay? And remember, we want to take 4.5 times 4.5 first. And that's going to give us 20.25 pi. All right, so that's going to be our exact answer. And then to approximate it, we're going to take that and we're going to multiply it times 3.14, and that's going to give us 63.585. Okay, and since we have a 5 right there, we want to round up. So we would have 64 kilometers. Okay, here it says UZ plus YZ equals 10 kilometers. Okay, UZ and YZ are both radiuses, right? Radii. So if they add up to 10, then we can divide 10 by 2, and we know that they equal 5 each. Okay, so then pi would equal, or area would equal pi 5 squared. Okay, 5 times 5 is 25. So we have pi 25, or 25 pi. Okay, then we're going to take 25 we're going to multiply it times 3.14, and that's going to give us 78.5. Okay, since it's a 5, then we're going to round it up to 79 kilometers. Okay, so that would be the answer to C. This one says the distance from M to a point on circle M is 14 millimeters. What is the exact and approximate area of circle M? Use 3.14 per pi and round your answer to the nearest millimeter. Okay, so here we have circle M, right? And remember, we name a circle by the center point. Okay, so here, if it says the distance from N to a point on circle M is 14 millimeters, that means that we're talking about the radius, all right? So 14 is our radius. So we have pi 14 squared, okay? So we're going to take 14 squared first, okay, which is 196 pi millimeters would be our answer. Exact, okay? And then from there, okay, we can multiply that times 3.14, and that's going to give us 615.44. Okay, since this is a 4, we're not going to round this 5 up, we're just going to leave it the same. So we would have 615 millimeters. Okay, this one says approximately how much area can be monitored by a security camera mounted in the center of a circular room with a diameter of 50 feet. Okay, so the diameter of this room is 50 feet. If the camera can rotate a total of 45 degrees. Okay, so what they're saying is that this angle right here is 45 degrees. And what they're wanting to know then is this area of this sector right here. All right, and so the first thing that we want to do is find the area of the whole circle. All right, if the diameter is 50 feet, then we know that the radius is 25 feet. So we have pi 25 squared. So we're going to take 25 times 25, and that's going to give us 625. And here it doesn't want an exact answer. It just says use 3.14. So we're going to take, so we have pi 625. So then we're going to take 625 times 3.14. And that's going to give us 1,962.5. Okay, so we can round that up to 1,963 feet. Okay, so that's the area of the whole room. Okay, now, okay, we want to know how much area this arc or this sector takes up. Okay, so here, if remember to find the percentage, right? This whole circle is 360 degrees. So we take 45 and we divide it by 360, okay? Now we want to reduce that as much as we can, okay? So just think of numbers that these are divisible by, right? They'll both divide by 5. We know that, okay? 45 divided by 5 is 9, and then 360 divided by 5 is 72, okay? And then you want to try out, and see if anything else, right? They can both be now divided by 3. Okay, 9 divided by 3 is 3. And then 72 divided by 3 is 24. Okay, we can keep going. 3 over 24, right? They can both be divided by 3, so we know this is 1/8. Okay, so we know that this arc takes up 1/8. All right, so if the whole room is 1,963, if we take 1/8 and multiply that by 1,963, okay, that's the same as 1,963 divided by 8. And that's going to give us 245.375, okay, or 245 feet. All right, so that would be how much area that this camera can take up out of this whole room, 245 feet. Here it says the square has side lengths of 12 centimeters. Use 3.14 per pi. What is the proximate area of the inscribed circle? All right, well, we know that the square has side lengths of 12 centimeters. So we know that the diameter then is also 12 centimeters. Okay, so the area then is pi r squared. If the diameter is 12, we know that the radius is 6. Okay, 6 times 6 is 36. We have pi 36. Now we have 36 times 3.14. So we have 113.04 centimeters. Okay, and it just says approximate, doesn't tell us what to round our answer to, so I'm just going to leave it like that. Okay, it says here, will the estimate be greater than or less than the actual area? All right, and so what it's asking is if you were going to just estimate what the area of this circle is based upon the square, okay, right, to find the area of the square, you would just take 12 times 12, right? Well, obviously the square here takes up more space than the circle, so the estimate is going to be bigger than the actual, right? Because if we just estimated and said, well, it's around 144, because that's what 12 times 12 is, then we know that it would be a little high because the circle is actually less area. Okay, here it says a regular hexagon with side lengths of 5 2/3 centimeters is circumscribed about a circle S. What is the approximate circumference of circle S? Okay, so remember a hexagon has 6 sides. So here if we have 1, 2, 3, 4, 5, 6, and then we have a circle that's inside of it. Pardon my horrible drawing. So to find the approximate circumference of circle S, we're just going to take 5 2/3, right? That's one of the sides. And we're just going to add up the sides of the hexagon to get an approximate circumference, right? Because since a hexagon has so many sides, it's pretty close to a circle. So we would just take 5 2/3, and we would actually just multiply that times 6. Okay, so I'm going to turn this into a mixed number, right? 5 times 3 is 15, plus 2 is 17. So I have 17 over 3. And then I'm going to divide that by, or multiply that times 6 over 1. So I have 102 over 3, which is 34. Okay, so the approximate circumference is going to be 34 centimeters. Okay. Now it says, will the estimate be greater than or less than the actual circumference? All right, well, think back about what we said about the square, right? Now, here we could actually find a pretty close approximate of the circle, right? Because we knew what the diameter was. Here we don't actually know what it is, so, but we do know that the hexagon still is longer, right? It takes up more space than the circle, so we know that actually 34 is probably a large estimate. So we're going to end up with a number that's bigger than what the actual circumference is going to be. And that is the end of area and circumference of circles.